All right. Well, happy Friday, everybody. It's the end of week 4, and some of you had midterms this week already. Um, but so I hope those went okay for you guys. But yeah, we'll wrap up our kind of lecture on regular expressions, and we'll take a look at that. And yeah, we'll wrap it up here. Okay. So I think we left off talking about character classes, and we said, we can kind of represent digits. There's shortcuts to represent some of these things. So digits can be represented with a /D. Non-digits can be represented with a /D, a little w for word characters, which is basically all letters, digits, and the underscore. And non-word characters is anything but those. And then any kind of space characters, and space characters are useful because we have both regular spaces and non-breaking spaces. And, sorry, that's okay. And then there's different kinds of white space characters, including tabs and new lines and things like that. And so regular expressions will search for those. Okay, so as far as character classes go, we can look for things like P followed by a digit. P/D will be P followed by a digit. And so what will we match? We will match not this, not this, not this. We will match this because we have P followed by a digit, okay? Not any of these other things. Okay, so we get false on everything. We get true for the P0, and then false for everything else. Okay, here when you use the capital letter, so little d for digit, capital D for non-digit, it's basically going to be just kind of the inverse of this. All right, so we're going to match everything except this, where we have P followed by a digit, and then these are all P followed by a non-digit, and we're going to get true for all of those, false for this. Okay, this is P followed by a non-word character. Non-word character would be well, word characters are letters, digits, and underscore. So non-word character would be not the letters, digits, or underscore. And so the only example of a non-word character, P followed by a non-word character, is this. We have P followed by a dot. Okay, so we're going to get true for this and false for everything else. Okay, there are other ways to represent letters and digits and character classes, and you can use the POSIX character class. Okay, POSIX character class is supported by the Regexer engine in R, and these are just kind of ones that you can use. So instead of typing A through Z, you can type in lower or upper for a capital A through Z, and you can type in alpha for this, or alphanumeric, alnum for alphanumeric for this. Okay, and so these what's on the left is equivalent to what's on the right. Me personally, I think I prefer just using this to represent the letters and the digits, but you're allowed to use this as well. Okay, all right, for digits I just use /D, and then for lowercase letters I just use this, and uppercase I use that. But you can also use it this way. Okay, and so so here's just a few examples, right? Do you detect anything with a letter? Okay, anything with a letter. So all of these have an example of a letter, right? Even these, right? We have a P here that detects a letter, and that's going to qualify. Here, do you detect anything with a digit? So this is the only thing. This has a digit, and the 3 here has a digit. So those are the only things that return true, and everything else returns false. Okay, and of course you can incorporate other aspects of the pattern. You can put a P followed by an alpha or things like that. We have other characters, or these are not really characters, but these are what we call anchors. And you have at the start of a string, there's an anchor. At the end of a string, there's an anchor. And then actually within and at the end of every word, that you have word boundaries and non-word boundaries. Okay, and these are to indicate that you want to find a particular pattern at a certain location. So here I have the text, the quick brown fox jumps over the lazy dog. That's intentional with to have 2 instances of dog. And we're going to say, go and find the pattern THE, and replace the pattern THE with a dash. Okay. And we're saying replace all of them. So it's going to go through and it's going to find this THE, replace it with a dash. It's going to find this THE, replace it with a dash. And that's what we get. When we replace it with dashes, we get dash, quick brown fox jumps over, dash, lazy dog, dog. Okay. Here we have the caret anchor, which says start of a string. Okay, only at the start. So it needs to be at the start of a string, THE. Okay, replace start of the string THE with a dash. And therefore, when we replace that, it's only going to find the THE at the start of the string. And this THE, which appears in the middle of the string, does not match this because this says it must be at the start of the string THE. Okay. The caret and the \A are equivalent. These are just, they're 2 ways of saying the same thing of must be at the start of the string. So \A, when R looks at this, \A is the same thing as start of the string. So this is saying start of the string, THE. So it's going to be the exact same thing as this. And then here I have THE $, and this means we want THE at the end of the string. And so it's going to go through here. It's going to find this THE, but it's not at the end of the string. So it's not going to do anything. Finds this THE, but it's not at the end of the string. And so it goes through and it finds no match and nothing gets replaced. All right. So far, so good. Okay, here we've got dog. And we're going to replace the pattern DOG with a dash. So it's going to replace this DOG and this DOG. And we get that. Here I've got DOG $. And so it's going to find this DOG. It's not at the end of a string, so it skips it. It finds this DOG. It is at the end of the string, so it's going to replace that with a dash. So it's only going to replace this with a dash. And we get lazy dog, dash. Is that okay? All right, my dog is barking now. This is for a word boundary. Okay, /B says replace anything, all word boundaries with a dash. Okay, and this is going to look a little funny because word boundaries don't take up any space in the text. Okay, but there is a word boundary at the beginning of a word and at the end of the word. So between the W and the quote mark, there's a word boundary. Between the S and the space, there's a word boundary. Between the space and the J, there's a word boundary. Between the P and the space, there's a word boundary. And between the space and this J, there's a word boundary. And so all of those word boundaries are going to get replaced with a dash. And this is basically where all the word boundaries are located. Wherever you see a dash, that's where a word boundary exists in this original text. Okay. If I do something like this, replace all the non-word boundaries with a dash. All the non-word boundaries with a dash. Where are all the non-word boundaries? Well, there's a non-word boundary between the W and the O. There's a non-word boundary between the O and the R, between the R and the D and the S. Okay, and so on and so forth. And so when we run that, we get dashes between the W and the O and the O and the R and the R and the D and the S. And, you know, and that's where all the non-word boundaries are. Okay, and so this is, you know, if you needed to show like how people spell out words at the spelling bee or something like that, you could use non-word boundary gets replaced with a dash. And now it looks like we're spelling our things, right? WORDS, words. Okay, so let's take a look at how we could use this. So if I say replace this pattern, word boundary UMP, okay, this is basically saying replace the word boundary UMP with a dash. So anytime you find UMP at the start of a word, okay, because that's what we're effectively saying here. We want UMP, but only at the start of the word, replace it with a dash. And so it's going to go through here, and it's JUMP is not going to match because this is not at the start of a word. But UMP at the beginning of umpire will, and umpteenth will also match. So we're going to replace those UMPs with a dash. Okay. Here it says find UMP, but it must be preceded by a non-word boundary. Non-word boundary UMP. And so it's going to go through and it's going to say, okay, you have JUMP here. This UMP is not preceded by a word boundary. It's a non-word boundary in front of it. So it will replace that, right? So it finds jump, jumping, umpires left untouched because it's not a word boundary before the UMP. Pump gets replaced and lumps get replaced, but umpteenth and umpire don't get replaced because they are not preceded by a word boundary. Okay. All right. Is that okay? The difference between the word boundary and non-word boundary UMP? Okay. Okay, so tell me what is going to get, which words are going to get affected here? You can unmute yourself if you want. UMP/B. UMP followed by a word boundary. Okay, so it's going to do jump and pump because those instances of UMP are followed by a word boundary. Okay. Okay, whereas the other ones, they are not followed by word boundaries. They're still kind of in the middle of a word, so they don't get replaced. And here we say UMP followed by a non-word boundary, and that's going to be all the other words, right? Jumping and umpire and umpteenth and lumps. All of those will get replaced with a dash. Okay. Great. All right. So what is the difference between caret 0 through 9, caret character class 0 through 9, and then character class caret 0 through 9, and 0 through 9 caret inside the character class? They look similar, but they're different. Okay. When you put caret outside of the character set, it's an anchor. This represents at the start of the string, we want a digit. So, right, so it says the string must begin with a digit. Here, the caret inside here indicates negation. So this just means a character that is not a digit, right? So this will match any character that is not a digit. And here, this is a character set with 0 through 9, but here the caret is not at the beginning. So this is going to be the literal character. And so this will match any digit or the caret, okay, or the literal caret. So the caret takes on different meanings based on its position, placement in the pattern. All right, so this means at the start of a string. And that's just one thing that kind of sometimes students forget, that when it's out here, it just means at the start of a string. Okay. We can specify quantifiers. Quantifiers can be attached to literal characters, character classes, or groups to kind of match repeats, okay? And so these are the quantifiers, and you know, in the beginning, you'll get these confused and mixed up, but then after a while, you'll get used to them. The star means 0 or more, okay? 0 or more, and it behaves in a greedy fashion, and I'll explain what greedy is in a moment. But star means 0 or more of that thing. The plus means at least one or more of those things, okay? The question mark is basically, this is an optional thing. You're going to get 0 or 1 of these things, all right? And then if you put numbers inside curly braces, it means you want exactly this number, exactly 3. 3 comma is 3 or more. 3 and 3,5 is, you know, anything between 3 and 5. So 3, 4, or 5. Okay, so here we'll start off without any quantifiers. We'll just do take this thing. We got words or numbers 9,876 and combos 1, 2, 3, like password underscore 1, 2, 3, 4. And we're going to say replace any, this is a space character, lowercase s for space character, with a dash. All right, and so this I don't think is any surprise. We're going to replace all the space characters here with a dash. And that's what we get. Okay, here I say capital S, so non-space characters. Non-space characters will get replaced with a dash. Okay, so that's basically everything except for the spaces. Everything that's not a space is going to get replaced with a dash. Okay, so words is going to become dash, 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 dash. And or is going to become dash, dash. And numbers becomes a bunch of dashes, and this is what we get. So we've replaced all the non-space characters with dashes. And this is the result. Okay, here, string replace all. This says replace one or more. The plus means one or more. In a greedy fashion, replace one or more with a dash. And so basically, anytime there are multiple dashes in a row, okay, anything that counts, this counts as multiple non-space characters, all 5 of these are going to get replaced with a single dash. Okay, this OR counts as multiple non-space characters gets replaced with a single dash. Numbers, NUMBERS, multiple non-space characters gets replaced with a single dash. So basically all these instances of multiple dashes will just get replaced with a single dash. And we have 1, 2, 3, 4, 5, 6, 7, 8. And we still have 1, 2, 3, 4, 5, 6, 7, 8 dashes down here. Just here we have multiple dashes for each of these things, and here there's just one. Okay. This, what's the difference between this? Non-space versus a word character. Okay. The only character up here that is not a word character, that's the difference between a non-space and that is a non-space character but isn't a word character, is this comma. Okay, and so the result's going to look a lot like this, except we're going to have a comma in the middle. The comma doesn't get replaced with a dash. Okay, so the spaces are left alone, and the punctuation, in this case a comma, is left alone. Underscore counts as a word character, right? So something like this counts as a word character. Okay, here we're going to say replace any digit with a dash. Okay, and so 9,876 will become comma or dash, comma, dash, dash, dash. 1, 2, 3 gets replaced with dash, 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 and 1, 2, 3, 4 gets replaced with dash, 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 dash. Here we're going to say anything that's not a digit, replaced with a dash. Okay, so anything that's not a digit, only the digits will remain. Okay. So the spaces will get replaced, the letters will get replaced, anything that's not a digit gets replaced, and only the digits remain. Okay, so we get this. So we get dash, 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 9, dash, 876, a bunch of dashes, 1, 2, 3, a bunch of dashes, 1, 2, 3, 4. Anything that's not a digit gets replaced with a dash here. Okay, here we say one or more digits replaced with a dash. Okay, so basically anytime we see multiple digits in a row here, they're just going to get replaced with a single dash. So we get the dash, comma, dash, and then these multiple digits get replaced with a single dash. These multiple digits get replaced with a single dash. Okay, and here we're going to say take one or more non-digits and replace it with a single dash. Okay, so anytime we see multiple non-digits here, they're going to get replaced with a single dash. Okay, and we're left with this. Okay, so this is what we started off with. We said replace any one or more non-digits, which is all of these things, replaced with a single dash. One or more non-digits replaced with a dash, things like that. Okay, here I put a /D with a question mark. This says replace 0 or 1 digits with a dash. 0 or 1. Okay, the question mark, when it comes to replacing, it behaves in a slightly funny way, because it says, oh, well, there's 0 here. Okay, there's like a word boundary here. There's 0 digits here. So we're going to replace this word boundary with a dash. There's 0 digits between the T and the H. We're going to put a dash in there. Okay, and you end up getting something that looks like this. Okay, you end up getting dashes where there's 0 digits. Here, where there's 1 digit, it replaces them with digits. And I think it counts this as a word boundary here. I'm not sure. And so you end up getting 5 dashes here. Word boundary in front of the A gets replaced with a dash. The 0, 0, 0, you know, all of these things with 0 dashes. 0 digits get replaced. Here we're going to say we want exactly 3 digits, 3 adjacent digits, /D quantifier 3. I want exactly 3 of them. Replace it with a dash. Okay, Now, the regular expression engine reads left to right. It reads left to right. So it's going to come along here. It's going to say the space here, no match. And then it finds 199. And it's going to say, okay, that matches 3 digits, 199. And it's going to replace the 199 with a dash. And then it moves on to the 6. And then it hits a space. Okay. And so that's no longer going to match. And so it replaces the 199 here with a dash, but leaves the 6 intact because it's reading left to right. Okay, 310 gets replaced with a dash. That's 3 digits in a row. 123 gets replaced with a dash. That's 3 digits in a row. And again, 1, 2, 3, 4, it reads left to right. So it finds the 1, 2, 3, and it replaces with a dash. And then it leaves the 4 intact, okay? Because 4 space no longer matches this pattern, right? If we had 1, 2, 3, 4, 5, 6, then we would replace that with a dash dash. And then the 5 doesn't match, so that just is left there. Here it says replace anywhere from 2 to 4 adjacent digits, okay? And this is going to do where it can, right? So it's going to find 1996, and it's not going to say, well, I could do 2. I can do 19, replace that with a dash, and 96, and replace that with a dash. It's going to say, oh, I can match all 4, 1996, and it replaces it with a dash, okay? 310 fits in between 2 and 4 characters. 123 fits between 2 and 4 characters. 1234 counts between 2 and 4 digit characters. But the single digit 5 does not match this pattern of 2 to 4 adjacent digits. And so that is left untouched. This does not match the pattern. Here, let me give you a quiz answer. Today's first quiz answer is the letter C. The letter C. C as in cat. Okay. All right. So let's talk about what greedy and ungreedy matching is. Okay. So the star. So going back to the quantifiers. So if you remember, the dot is a wild card. It's going to match any character, spaces, punctuation, letters, digits, anything but a new line. Okay. So it matches everything. And so it's a wild card. It matches everything. And the star is the 0 or more quantifier. It's going to match as much as it possibly can. Okay, 0 or more, and it's greedy. Okay, and so here it says, I want to find a pattern that begins with a capital P, and then any characters, spaces, letters, whatever, but the pattern has to end with a little r here. So start with a capital P, end with a little r, and I'll take whatever you can find, spaces, punctuation, letters, numbers. So, and it's going to try to find as much as it can. And so when it looks at this, it's going to start at the capital P, and it goes, yes. And it takes this, goes to this R, and it keeps going. It says, does this still fit the pattern? Yeah, it does. And it keeps going, and it's going to end here. It's going to end here. It's going to reach this little r here, and it's going to say, this matches the pattern. It started with a capital P, ends with a little r, and there's a whole bunch of characters in between. Okay. You can make it ungreedy. Ungreedy, you put the question mark. You put the question mark here, and it makes it ungreedy. Okay, ungreedy says find this as soon as you find something that can close off the pattern, close it off. Okay, close it off. So it's going to start at the capital P. It's going to go E-T-E little r, and goes, okay, that matches the pattern, and it stops. Okay, so this is the ungreedy. Okay, so greedy is going to find the biggest pattern it can find that matches. Ungreedy is going to basically find the smallest that it can match. Okay. Now, string extract all says, you know what? I bet we could find multiple things that match this, right? We got Peter and Piper. Okay. These both fit, and it reads left to right. So it's going to take the capital P, E-T-E-R, and it's going to pull that out as a match. String extract all says, go through this entire thing and find everything you can. And it says, okay, well then we go start with a capital P in Piper, and it finds the R, and then it finds no more capital P's, so no more matches, and it pulls out Peter and Piper because those match the pattern. We have here, I'm going to say, you know what? Let's take either a capital P or a lowercase p. Capital P or a lowercase p. All right. So this is going to find the Peter and find the R. And remember, it reads left to right. Then it goes Piper, and it finds the R and stops. And then it goes to picked, this P here, okay? And it matches. And it's going to try to find until it can close off the pattern. And there's no R, no little R, no little R until it gets to here. Okay, it reads left to right. So it's going to pull out Peter and Piper and picked a peck of pickled pepper. Okay, and so that's string extract all used with ungreedy matching here. Okay, it's not capable of going along and saying, you know, this is the smallest possible match I could find. Okay, because it reads left to right. It reads left to right. Okay, here we have, and you know, all of these things, you can, slide 128. I think one of these things, one of the things is Regexer. This is a website. And this is just a good place to kind of just test out regular expressions, right? So if you want to say like, okay, here's some text. I want to test out some regular expressions here. You can come along here, you type in some text. There's already some text to start off with. And you can say, you know what, I want to find, you know, p dot star r, okay? And it does this, and you go, okay, well, you know what, I actually want to make it ungreedy, and it's going to find this, and you can say, okay, you know what, I want to do either capital P's or lowercase p's, okay? And it tells you kind of all the things that kind of match this capital P, lowercase p type of stuff. And you can go along and you say, well, you know what, this isn't quite what I want. You know, I want something only at the start of the words or something. I'm sorry, word boundary, only things that kind of start with this. I want to, proudly, I don't want that. I want to, you know, I don't know, whatever you want, okay? and so this is a great place, I think, to kind of just test out your regular expressions, and then the best is in here. It explains what it is that it's matching. Okay, so it's saying like, oh yeah, we want a word boundary, we want this, and things like that. And so so this Regexer site is a great place to just kind of test out regular expressions and see if it's matching, things like that, right? And so, you know, in your homework, oh well, I'll explain. You have to kind of pull out wins and losses from the managers column, and you can just kind of copy and paste some text and into this thing here, and you can just test out different patterns to see if it's giving you the results you want.
Professor, I have a quick clarifying question.
Yeah.
So like, is the only thing that's different between the greedy and ungreedy is that the greedy just stops once your condition is like made, but then ungreedy just keeps on going until the string is over?
So greedy will try to get the biggest bunch of text that matches the pattern. So greedy will try to get as much as it possibly can that still qualifies as the pattern. Ungreedy is, as soon as it can end the pattern, it's basically, ungreedy tries to find the shortest pattern that it can return, but it reads left to right. Okay, so it reads left to right. Ungreedy is going to find the shortest. As soon as it matches, it's going to end. Greedy will try to find the biggest thing. Again, reading left to right is going to try to find the biggest thing that qualifies as matching the pattern. Okay, so we can also do this thing called grouping, capture groups. And this is really powerful stuff. and you use parentheses to define a group. Okay, and that's going to group together parts of a regular expression, and you can use it to define what we call capture groups that can then be referenced later or can be extracted for use by using match. Sometimes you want to kind of group things together, but you don't actually want to capture it, and you'll specify this question period, and that becomes a non-capture group. And I'll just show you some examples here, okay? And you'll use capture groups with match and match all. So here, so basically, when you're trying to read a pattern, you just look at the characters in there, and you kind of ignore the parentheses, except you know that there's groups here. Okay, so this A parentheses BC parentheses D matches the text ABCD, but this group right here, this BC, is a capture group that's going to get kind of pulled out. It's going to get matched. Okay, this says match ABC, and it gets grouped, but we don't actually want to capture this. This is a non-capture group. Here I've got parentheses, and it's going to must match this literal text A, B, C, D, E, F, G, H, I. Okay, and the groups are A, B, C, and G, H, I. Okay, here is it groups MRS, MS, and MR. These, the vertical bar here represents OR, and they're kind of used to find you know, alternate versions of patterns and stuff. And so this says or this. And then later on, I'll show you an example where you can kind of back reference a group that got captured. Okay, I think this is best explained with examples. So let me just show you this. Okay, so here the pattern I'm defining is B, C, D, E, F, G, H, I. Okay, and you know, capture groups don't really quite make sense for literal things like this, but I'm going to just start off here. And basically it says you got to find this exact pattern, B, C, D, E, F, G, H, I. Okay, and that exists here, B, C, D, E, F, G, H, I. And because we have parentheses around BC and parentheses around DEF, those get captured. Those get extracted, like separated out. So this is the text that matches. This text matches this pattern, but then the parts in the parentheses get pulled out in their kind of own columns here. This thing has a question mark in front of it, question colon. And so it says, you know, don't give it its own column. We don't actually want this, okay? Here I have A, B, C, D, F, G, H, I, but I is capital. And so it still has to match this literal pattern, okay? And it doesn't find a match. It doesn't find the capital I here. It doesn't find the lowercase I here. So there's no match. There's no match here. And then there's nothing in as far as these capture groups go. No capture groups get pulled out. So let me just show you some more examples here. Here I've got this text, Mr.Smith, comma, Mrs.Lee, comma, Ms.Garcia. Okay, and our pattern is going to be MRS or MS or MR. Okay, and it's inside a capture group. So we're going to say, okay, do you find any of these things here? Okay, and it says, yeah, we found, we match all of them. Okay, we found MR and that matches this. We found an MRS that matches that, and an MS, and that matches that. Now, this shows us the entire pattern that matched, okay? Okay, and because it's inside parentheses, it gets extracted as well. Okay, now it's a little redundant here because the entire pattern is in a parentheses, so the entire pattern that matched gets pulled out. I'll show you in a moment how this all kind of works together. So right now it seems a little redundant like this. But you have to, if you want to use the OR operator for different literal patterns, you kind of have to use the, you have to specify it as a group to kind of group things together. So this is the pattern MRS or the pattern MS or the pattern MR. Now, it reads the patterns left to right as well. And so if I write my pattern like this, MR or MRS or MS, it's going to go along here and it reads left to right, giving kind of preference in the order listed. And so it's going to say, okay, Mr.Smith, okay, we found MR. Then it goes to mrs.lee, but it says, okay, oh, I found an MR here, and then it's satisfied. Okay. Whereas, you know, in this case, we actually want to capture the MR in the entire MRS here. Okay. So this is not going to work because it reads left to right, and it's going to say, oh, I found that something that matches the MR, and it's done, and so it finishes here. So if you have patterns that are kind of like one is more restrictive than another, you should put it in the most restrictive to the less restrictive order, if that makes sense. Okay. Here's kind of an example that didn't use any kind of OR operators. And I have an MR question, S question, right? So question means it's optional. I want an M followed by R, maybe yes or no, 0 or 1, followed by an 0 or 1 S's. So basically the S is optional. So this will match MR, it'll match MRS, and it will match MS. Okay. There's another thing that this will match that's technically not one of these patterns. It's not MRS, MS, or MR. What will this match that's not technically a title? Just capital M. Yeah, it will match just to capital M. Okay. Yeah, because the R and the S are now optional when you put it like that. Okay, so let me just show you how this could work, right? So here I've got the same capture group, MRS or MS or MR, followed by inside a capture group, followed by a literal dot and a space and one or more word characters, and we want to put that inside a capture group. Okay, and the text that we're working with is mr.smith, comma mrs.lee, comma ms.garcia, comma Andy space Hope. Okay, so we're going to run the capture on this, and it's going to find, okay, the first column is the entire pattern that matches. So Mr. Smith, Mr.Smith matches, okay? Mrs. Lee without the comma matches, and Ms. Garcia matches, okay? Andy Hope does not match, okay? So it pulls that. And then the parts that are in parentheses get extracted or pulled out, matched as their own columns, okay? This part, the one or more word characters get put into its own column. So here, this capture group is basically the title, and this capture group is basically the last name. So we have Mr. Smith is the entire pattern that matches, and we pull out Mr., we pull out Smith, and we pull out the MRS, and we pull out Lee, pull out the MS, and we pull out Garcia. Okay, so we're able to establish capture groups like this to pull out kind of last names, or whatever it is that you want, right? You can establish capture groups, and so again, you know, in your homework, you're going to have to deal with kind of these manager patterns where there's like a name followed by, you know, how many wins and how many losses separated by a dash, and there's stuff like that. And you can define, and you can say like, you know what, these digits that come before the dash, those are the wins. The digits that come after the dash, those are the losses. And we want to pull those out as kind of their own columns. Okay. And so, so here, this is, I'm going to take the exact same pattern here, but I'm going to just put in a question colon here. And this just means this becomes a non-capture group, Okay. So as far as the text that matches, the same kind of text matches. Mr. Smith, Mrs. Lee, Ms. Garcia, Andy Hope doesn't match here. But here we are not interested in the title, and so we're not going to dedicate a column like over here. We gave a column to this capture group. We're not going to give a column to that capture group, and it's just going to pull out this part. This is the capture group, and we'll pull out the names Smith, Lee, and Garcia. Okay, let me give you another quiz answer. Another quiz answer is B. B as in bear. B as in bear. That's your second quiz answer. Okay, so far so good for capture groups in this. Okay, so this is some cool stuff, I think. First answer for quiz answer was C. Okay, you got C and B. C and B. Okay, so here the text is George Washington, comma, John Adams, comma, Thomas Jefferson. Okay, and the pattern is going to be text, word characters, space, word characters, and an optional comma. Comma question, right? Comma question means the comma is optional. Because if I didn't make the comma optional, then I wouldn't capture Thomas Jefferson. Okay. So here the matching text is George Washington, comma, John Adams, comma, and Thomas Jefferson. And we pulled out the name George, John, and Thomas in the first capture group. And we pulled out Washington, Adams, and Jefferson in the second capture group. Okay. Now what you can do is you can take the capture groups and you can run something like a replace. You know, earlier we used replace, and it was just like replace digits with dashes or replace word characters with dashes. But you can use stuff in the pattern. So here's my pattern, and we're going to say replace that with these back references, /2, comma, /1, semicolon. Okay. Why do we want to include the comma? Well, because what I want to do is I want to replace this text with a listing of the first 3 presidents, but written in kind of last name, first name order. So here, /2 represents the second column. So /2 will be Washington. We're going to replace this George Washington, comma, with second column Washington, comma, space, first column George, semicolon. We're going to replace John Adams, comma, with Adams, comma, space, John, semicolon. And so this text, George Washington, comma, John Adams, comma, Thomas Jefferson, becomes Washington, comma, George, semicolon, Adams, comma, John, semicolon, Jefferson, comma, Thomas, semicolon. Okay. And I think this is kind of magical. like we were able to replace this with with one line of text, right? We just kind of define this pattern and we define the replacement string, and it replaces it in this form here. Okay. Whereas before you might have had to run some kind of thing and put it in Excel, and you get the 2 columns, and then you'd have to kind of paste it back together into this thing. But a regular expression allows you to kind of do this text replacement, kind of this content aware text replacement, where you capture the first group and the second group, and you can then rearrange them as needed. All right, so let's look at this pattern. Okay, so as you get more comfortable with regular expressions, you're going to see patterns like this, right? You're going to see patterns like this, which right now might feel completely unintelligible or like complete nonsense gibberish. But if you read them, again, the key for understanding regular expressions is to read them left to right. Okay, so what does this say? It says we want a word boundary. So it's start of the word, some text, 1 or more word characters. So we want a word, and then we want a space, 1 or more spaces, /1. So we want the same thing that we captured. Okay, so this is a capture group inside the parentheses. So you want text, space, and the exact same text that we captured here, followed by a word boundary. Okay. And so what this will do, okay, our text is the quick brown fox jumps over the lazy dog. And what this will do is it's going to find instances of words that got duplicated. Because here it's saying we have the word, space, and whatever we captured here, which would be a duplicated word, a word that got repeated. Okay. And again, you can kind of play around with stuff like this in so you would do something like we want the word boundary followed by 1 or more word characters, followed by a space, followed by the back reference, followed by a word boundary here. Okay. And so here it says and if you do stuff like you put kind of matches here, then you can say, oh yeah, anytime the text gets repeated, it matches. So again, play around with that. All right, here's a telephone number example, okay? And so here it says we want the literal parentheses, but it's optional, question mark. We put a question mark after the literal parentheses. And then we have a capture group, okay? And a capture group is going to be a digits 2 through 9, because in the US, your phone number is not allowed to start with a 0 or 1, okay? Digits between 2 and 9, and then 2 followed by any 2 digits, followed by optional closing parentheses, okay? And then an optional character, either a dash, a space, or a dot, okay? That's an optional character because we got a question mark here. And then we have another capture group, okay? The capture group of a digit between 2 and 9, followed by 2 digits, an optional character of dash, space, or dot, and then 4 digits here. Okay, and so we can apply this to, here I've got this vector of text. The vector of text is Apple 1-800-786-1000. That looks like a real phone number. 310 space 209-626 1626. That looks like a phone number. This looks like a phone number, right? Because if you have like enter your phone number in a field, sometimes people just type things, right? Here they didn't put in any spaces. Here they put in 2 phone numbers, work, semicolon, home, okay? Formatted this way, right? This is the only thing that doesn't look like a phone number because it starts with a 1. Okay, so we run this and string extract pulls out just the first match. So it finds no match for Apple. It finds a match for here and it ignores the leading one and it says, okay, 800-786-1000. It says, okay, this is a match. This is a match. This is a match. Okay, and then here, it just takes the first one and it says this is the first match. And then there's no match here. Okay. If you want to get both of these here, you can use string extract underscore all. String extract all will get both. Okay. And because here this is a vector of length 8, okay, or no, 7, vector of length 7, it returns a vector of length 7. It just each element can have at most 1 match, so it just returns a vector of length 7. Here returns a list of length 7. Here for Apple, there's no match, it returns character 0. For each of these, there's only 1 match and it returns that. But for this, where there was 2 entries that matched, it returns both of those. Okay, so we have a list of length 7. Most of the entries in the list are vectors of length 1, except for number 6, which is going to be a vector of length 2 because there were 2 matches here. And then there was no match here, so we get a character 0. Is that good? Okay, you can rather than extract, you can run match, and it finds all of the text. And again, match just pulls out the first one, and it returns kind of columns here. And then match all will return a list, and every element in the list is a matrix of 3 columns. Okay, and here, because there were 2 things, it returns back a matrix with 2 rows and 3 columns. Okay, whereas match just returns 1 matrix where there's 1 row for every entry here. Match all gives you a list, and in those the matrices can have multiple elements. Okay, and so if you have match all, you can then kind of bind them all row wise and just run through it, and you can get kind of all of these things that match. And then you can if you want, here we can take, so these ended up with kind of non-standard appearance, right? Because some of these have dashes, some don't, and some have dots and stuff like that. So we can go through and we can take this column that isn't kind of standardized, and we can say, you know what, we want to take that 3rd column and we want to fix it, right? And so this is where you can do capture groups, and you can say, I want the first capture group to be the first 3 digits. Then we have an optional dash, space, or dot, followed by 4 digits. That's the second group. And then I want to replace the text there with, the first capture group dash second capture group. And so it goes through, and this is all fine, but 208 dot gets cleaned up. This thing where there's no space gets cleaned up. Where there's space there gets cleaned up, and things like that. So you can kind of clean up your text this way. And so this is these are the power. This is the power of regular expressions as far as like handling text, cleaning things up, replacing things like that. Okay, we're gonna run out of time. We're not gonna cover. I won't cover the look arounds here, but you can read through those. Let me give you the last quiz answer. Last quiz answer today is E. E as in elephant. E as in elephant is your last quiz answer for today. I'll let you just read these slides on your own if you're interested. And that'll be it. Okay, so we'll end here for today. Have a good weekend, and we'll see you guys on Monday, week 5. All right, see you then.